Welcome back, everybody. Allow me to introduce our next project speaker, joining us from New Rock, building products from ash, Daniel Rahme. Daniel is the Director of R&D and Environment for New Rock Technology, with close to a decade of experience in managing various successful R&D projects across the globe. Daniel specialises in engineered rock technologies and regularly collaborates with universities in order to undertake the supervision of PhD and master's students to showcase new engineered rock technologies, processes and products. Daniel has developed many new applications with the New Rock process and has helped pave the way for a net zero future with the building and waste industries. Please welcome Daniel Rahme.
Thank you, Nicola. Just before we get started, I'd like to acknowledge the traditional custodians of the land where I am, the Wallayu Medical clan in the Ryde area of New South Wales. And a big part of our technology is to clean up the lands that were once owned by the traditional custodians. So we do want to acknowledge them before I get started. So New Rock technology has been part of my life for a very long time. We are a zero emission, carbon negative technology that really thrives in the circular economy, because we are a complete cradle to grave waste recycling and land renewable services technology. This is our small scale plant that we have running up at the Mount Piper facility in Lithgow, New South Wales, where we've been making building products for the last 5 years. Before that, we had been making building products for the last 27 years, doing that in smaller factories in different areas of New South Wales. We've been making products in that time for building projects of our own and for testing for different waste streams for different companies. Our unique process is a carbon negative and zero emission process. We are completely cold cured. Our binding system is not that of a traditional Portland cement product, where we do not use any quarried materials. We don't use any firing whatsoever. So our emissions are almost zero. And once we get to a fully renewable grid, our process will have zero emissions because of that. We've done testing on coal-fired power station ash, steel mill waste, non-ferrous metal slags, aluminum red mud, hard rock mine tailings, and coal tailings and washery tailings from the coal mining industry, and have been able to create several products out of those waste streams and test them to the Australian standards and develop different products based off of the waste streams. When New Rock is approached to remediate a site and we test the materials from that site, whether it be an ash dam or whether it be the steel mill waste or any of these wastes that I've listed, we don't try and make that waste fit into our process. We find a process and a product that is tailored to that waste stream. And in New South Wales alone, we have over 1 billion tonnes roughly of ash on the ground. I think it's another 150 million tonnes of steel waste on the ground. We have close to 60 million tonnes of red mud and several billion tonnes of mining waste on the ground from the various mine tailings. Recently, in the last couple of years, we have started doing testing on plastics and glass, tyres, and other waste streams that aren't recyclable with the different recycling processes. We do recycling on the waste streams that can't be recycled. So with household plastics, there are a large percent that can be recycled, but there is still quite a number of tons that does go to landfill, and those are the plastics that we do focus on. The same with the glass and with tyres. There are very few recycling processes for tyres outside of using it for playgrounds and other bedding, but we've developed a few processes with that. And our chemicals are actually a non-hazardous chemicals, and we manufacture our own chemicals on site. So it's a very different way of approaching the production of building products and the waste recycling in the sector in general. So to start with, we've come in a very conservative way in that we're focusing on a few products to get started. Those products are mainly bricks, blocks, pavers, and tiles and sheeted products. Those are those products. We start with those because we want adoption of our process. We want adoption of our materials. We want to be able to recycle as much as possible. So we haven't gone for products that are new, or we're not trying to reinvent the building industry. We've just recycled waste into products that are traditional, that can be used by any block layer or builder in the traditional way. So they're not trying to reinvent, they're not trying to learn on the job. They're just using a more sustainable product. As well as those materials, we do make our own aggregates and sands so that we avoid all quarrying whatsoever. And we think that quarrying is probably one of the biggest polluters and destroyers of land globally. And as a lot of us do know, there is sand shortage, and we are trying to help mitigate that shortage. So we're not tapping into sand resources that would affect environments or coastlines and deserts. Our goal is to be able to replace all quarried material with 100% recycled materials that are manufactured, as opposed to quarried. And the energy saving and the CO2 emission savings are about 98% by doing that. Right now on the market, we have a lot of common render bricks and blocks, and like I said, the sand and aggregates, which we have sold to some cement companies to make lightweight cement. By using our aggregate in their cement, they reduce their weight by up to 30%, depending on how much sand and aggregate they put in. Our masonry bricks, blocks, and pipes are on the market, but are in low demand. Well, not low demand, sorry, low supply. We have our pavers and sheeted products. We have been working with a few new manufacturing processes to develop sheeted products that would replace gyprock and be waterproof and not have any gypsum in them. And our sands and aggregates do go into road building and backfilling of mines. We have done a couple of projects on that. We don't have any leaching of heavy metals, so when we manufacture a product, it completely locks up all heavy metals. This allows us to be able to not use quarried materials, but at the same time not contaminate any ground with waste streams that could contaminate if used in the traditional Portland cement process. So some of the advantages of New Rock: we are less expensive because we're using recycled materials, and we do set up on a power station, and our energy usage is very low. We say up to 50% less expensive than traditional products. A common building block, Besser block, hollow block right now in the Sydney market is about $3.20. And if you're going for fire rated, you're looking at about $4.80. We sell a fully fire rated block into the market at $1.80 to $2 roughly, depending on the size of order. So the savings for a builder are astronomical. When you consider that when using our system, you would save on a 1,000 square meter home about 10% of the construction cost, which is usually the builder's margin. It is something that is quite unique. Our products are lighter. You can pick up a building block with one hand, and you can butter it and lay it on a wall with just one hand. So that saves all the block layers a lot of time, because they can lift more and they can use more in a day than a traditional product, which is double the weight of our product. Our products are fully fire rated. Our testing shows that we're 4-hour fire rated on a wall that is loaded. The most common concrete blocks, non-loaded bearing blocks, non-core filled only around 90 minutes. Our compressive strength, because we're able to adjust our binding process, we can make products that are double the strength required by the Australian standards to up to 8 times the strength required by the Australian standards. And that will vary from product to product, and the suitability of that product and the needs of that product. Our products are 100% salt attack resistant. We do 40 cycles on the salt attack tests, and it doesn't touch the surface, whereas concrete usually fails within 8 to 15. So our process is almost like a marine grade concrete, but we don't market it as such. But so our salt attack is extremely high for a standard product as opposed to a specialized product. We have high transverse strengths because of the way we produce it, and using spherical aggregates, it does help with the transverse strength of our products. Our products are super durable. Later in the slide, I'll show you an example of that. We have acoustic testing because ash is extremely has great acoustic qualities. It absorbs sound as opposed to emitting sound and letting it bounce around. Our thermal rating is through the roof because our ash is, you need 3,000 degrees to burn ash. Our common block core filled with render on one side and direct stick gyprock on the other has an R8 thermal rating, as opposed to a common block with the same system being R1.6 to R2 rating. And our process is totally acid attack resistant. You can submerge any of our products in a 40% sulfuric acid solution, and it won't degrade at all. And our process can be made to any shape article. We call it our new concrete. So any product or process that you need, we can shape it to form as long as it fits through our plant. These are some of the tests that we've done on our recycling materials for the recycling industry, where we've used plastics that can't be recycled, and we've used steel mine tailings at the bottom that couldn't be recycled to make bricks, and those bricks passed all the Australian standards. The bricks made with the shredded plastic and were 60% lighter than a common brick because the plastic made it that much lighter. And the tailings bricks were 4 times the strength of a common brick, but around about the same waste, because the density of those mine wastes are about the same of any quarried material. So, yes, these have all been our tests that we've been doing since 2018. With red mud, and one of the problems with red mud is that it does have a bit of radiation in it through the tailings and the proliferation of those tailings. We did a test for Oz Minerals on their tailings, where their raw tailings had a low radiation in them, but it was not suitable for any use. after going through our process, we had our block bricks crushed and analysed by ANSTO. Our process did not have any radiation beyond the standard radiation that you'd find in anywhere in the world at any one time, just from the sun's rays. So we've completely neutralized the radioactivity of that process, and that's through the fusion of our process, because our process is a fusion technology. It's not a casting technology. We fuse all of our materials together. Through this, we have applied for a few awards, and in 2020 we won the HIA Green Smart Building Product of the Year for most green friendly building product in Australia. Through the HIA is the biggest association for home builders, so this was voted on by all the home builders in New South Wales. In the past, we've also applied for some other awards. In 2015, we won the Sustainability Award and beat out a lot of heavy competition with that, as well as the Care Award for Best Remediation Technology. This past year, we entered the Colorado Clean Tech Industry Association Awards, and we won the best mining technology, cleanup technology, and beat several international companies in that process. The NUROC process itself is very straightforward, and our factories are very straightforward. They're not anything that's not on the market right now, but combined with our engineered rock process and the binding system, we're able to have a plant that it fits in a 1,700 square meter building that can run 24/7, 7 days a week, 48 weeks per year, with preventative maintenance every quarter, and produce between 250,000 and 500,000 tons of building materials, which directly equates to a one-to-one recycled material. For every ton of product we make, we've recycled 1 ton of product, because all of the material used in that manufacturing process is recycled material. Because with our process, because it is an exothermic reaction which creates its own curing environment, our curing time is only 8 hours. So we've designed our plants so that every 8 hours you have a full hours of production going out the door, and that allows us to work 24 hours. And it's a non-stop process. And with this, we want to be looking at cleaning up as much waste as possible. And this will allow us to do that in Australia. And hopefully within the next 40 to 50 years, we would have cleaned up all the waste on the ground, because there is so much. So as these plants, the 250,000 ton plant making building blocks, the standard 190 mil hollow Besser block, our product, that one plant will make 30 million blocks per annum to supply the market, and that's roughly about 0.5% of the market for building blocks. And because of this, our process is highly efficient and energy efficient. For every block we produce that is a direct carbon abatement of a cement product, because our process only uses 600 kilowatts an hour, and that's at startup. That's not at running, so that's at the maximum. With that, we're able to per hour you're looking at an energy saving of 98% when compared to a direct competitor's product. As I mentioned before, we have been building with this material for over 27 years. NUROC has been around for a long time, but it is a startup at the same time. Most of the building work using our products has been done internally. As you can see in the photos, One photo is a factory site where we halved the price of the concrete panels that the owner was going to use, and this took no time, virtually no time, and didn't require any craning of any products like a prefabbed panel would need. So it was a great time saver for the owner. And the other photo is a childcare centre where we saved $185,000 on the construction costs just by using our products and selling it at market price to the project. We didn't give ourselves a discount. So this, to show the durability, these two photos were taken from one of our original factories back in 1994. At that time, we had built a barbecue area at the back of the factory, and this was outside. On one side, you see New Rock bricks that were made from our process, and we had numbered them so that we knew what batch they came from. And on the other side, you see a traditional cement product that's on a stormwater pit, and they are roughly 10 meters away from each other in the same barbecue area. And you can see the cement product over the 27 years. These photos were taken in 2021. The cement product has lost all surface and is starting to deteriorate. And this, if you look at the New Rock product, our bricks are still look almost brand new. The whiteout has not been removed from the surface, even being exposed to the harsh weather in Australia, sun and rain. So it's a big indicator of the durability of our process. All New Rock testing is done third party. Our manufacturing for the tests are done internally, but all testing is done externally. And these are some of our partners. We've done testing with the ACCI, MECLab, CSIRO, ANSTO, University of Western Sydney, as well as the University of Wollongong. And several years ago, we did do a lot of testing with the University of New South Wales. This is some product testing, which is attached to the handout that will be given out after this. And again, this is a comparison sheet where we show exactly the direct comparisons of our product based off of Australian standards and what tests are required by the Australian standards, and the test requirements for them, what our product does and what the direct concrete competitors do. And this will speak volumes, considering we do all the testing under the Australian standards, but aren't also required necessarily to be a standard concrete product. One of them, I've added this in for this presentation, because we are in the Hunter and there is a lot of mining, is that we've developed the ground conditioner technology, which is a low emission fertilizer replacement. And it has been tested and we're ready to commercialize. We developed this technology because studying the farming industry, it is fairly well understood that soil erosion and topsoil degradation is a big issue in the reason why a lot of farming needs a lot of fertilizer now compared to 100 years ago. Some estimates are that we have about 30 years of topsoil left. There are some more extreme estimates, but the fertilizers used are usually powder fertilizers that do run off into estuaries and waterways and end up into the ocean, which can contribute to coral bleaching and other bad outcomes. So we've developed a ground conditioner using coal tailings, which is just a direct manufacturing of coal tailings using a pelletization process, the same pelletization process that we do in our block manufacturing. And this process can be tailored to different crops, so we can add nutrients to that to the crops. That if certain crops need certain nutrients that others don't, we can adjust for that and based off of farmers' needs. And the testing that we had done up at the with the Farmers Co-op up in New England showed that our process had a 25% increase in crop yield than the crops grown without our ground conditioner. And our ground conditioner is designed to break down over time, which will help revitalize that soil by injecting more carbon back into the soil, which is high carbon soil will always lead to high crop yields. So not only are we giving a fertilizer that will have a direct benefit to the current crops, it will also give a long-term benefit to the actual soil condition itself. And it is made with 30% coarse rejects from the coal mine and 65% washery tailings from that mine. And we do allow for about 5% additives, and those additives do change depending on the crop needs. Now, Nuroc's vision for the Hunter is grand vision. It might be a bit much, but we are looking to hopefully be able to have by 2030 16 manufacturing hubs. 16 manufacturing plants that will be recycling up to 8 million tons of waste that is on the ground and from households. And we would be hoping to be able to have 6 plants on the Liddell Power Station and 10 plants on Bayswater Power Station. Our plants will be there long after the power stations have closed down. So we don't need the power stations to keep running. Being a site remediation technology, our process is to be there for the long haul to clean up all the mess that is on the ground. And this vision will help create 560 direct jobs in the manufacturing centre for the Hunter community. And this will be one of the biggest manufacturing hubs in the world if we can pull this off. This would help the Australian economy and as well as the circular economy in the area. But right now we are in planning stage, and we have spoken with AGL about this, and they are very, very supportive. But we do have a lot more work to be done from here. So we do. This opportunity to present today was an excellent opportunity because we do want to engage with the local community in the area and see if there are companies that would like to help us with our own journey. Thank you very much. And below is the contact details to be able to contact us directly if you have any inquiries. So the presentation we've made available as well as a handout afterwards. Thank you.
Thanks, Daniel. That was really so interesting. And the thing that really struck me is, and it's probably not as widely known as it should be, this is not new technology. Why do you think we're not adopting this sooner across all levels of industry?
The pessimist in me wants to say the incumbents don't like us, but I just think the big thing is that timing is everything in this world. 27 years ago, if we said we were a green building products company, people would go, "Oh, you paint your blocks green, do you?" No. So it's a new world. We're looking at circular economy, and no one was talking about that even 2 years ago, really. So I think just being in 2022 and hitting this new decade, it is the time that renewable processes are being adopted more, and It's a new world. I mean, we had a conversation back in 1996 with a power station about using this process. They paid for all the testing. We showed the testing. It blew their socks off. They said, but by the end of everything, when it came time to talk about contracts, the words were, "Your process is amazing and we love it, but if I need, if I've got 60 hectares of land, if I need to dig another hole, I'll dig another hole." But that's just the mentality back then. So we're in a new world, and this is a great time for technology like this.
And technology is far better received these days as well. I'm sure you'd agree. Do you think
Exactly.
there would ever be a move by government to actually do some mandates to big industry to quantify their waste management and feed more into recycling processes?
I have been engaged with several levels of government in talks about that. Uh, Again, although we are 27 years old, we are still fairly new. So I think once our first plant, which is being built up at the now Pipers Power Station, a full-scale plant at 250,000 tonnes, once that is built, I think that the world will change that after that, and they'll be far more receptive because politicians by nature love them. They are risk averse. They don't want to be the person to sign off on something and then it fall apart. So I think after our first plant is built, there'll be a much bigger adoption, and I think that you'll find that a lot of incumbents in this industry will start to change their tune and also try and develop their own process similar to New Rock, which we're all for because we want to reclaim land that's being used to dump contaminated material.
Absolutely. And what an incredible solution to it, creating building products that are more sustainable in our harsh environments here in Australia. I mean, I
Exactly.
know what I would want to build my house with.
Exactly right. And with the timber, compared to the traditional timber frame product, with the bushfires that we have here and the high rains and the flooding that you can get, the main reason we haven't been building masonry houses like the rest of the world is that the cost to manufacture those masonry products in Australia is so high. Uh, it's just not affordable for anyone to build a house with a fully masonry house. So they have to revert to timber frame or fully timber houses. With this process and our goal, we'll be able to build fully masonry houses that will help the Australian people, uh, stay not be affected by the changing climate.
I think it's so exciting, and in all honesty, the renewable sector is just so vibrant right now. And I think you're right. It is about timing. It is about getting maybe not the early adopters, but maybe making people feel a little bit more comfortable about the process. But what a
Yes.
great way to repair some of the damage that we've done over the decades.
Oh, exactly. Thank you. Yeah, and I agree. It's great that we, as a people, global people, have started to focus on this. It is very important that we undo some of the wrongs that we've done in the past. I mean, we didn't know we were doing the wrong, but it still was wrong nonetheless.
Well, we learn the lessons, don't we? And this is one of the ways that we can rectify well, we say the sins of the fathers. Thank you so much, Daniel. I've thoroughly enjoyed your presentation.